I'd like to discuss different types of micrometers. This is not how to read the micrometers, but just to introduce you to different types of micrometers you may find in industry. What we have here is a standard micrometer, but we have these attachments that are placed on the end, and all it is it's just a small little ball that is going on the anvil and the spindle, and it snaps over it. This is used to measure parts with a radius, such as a bearing or something like that. You need to remember to subtract the balls that are sticking above the anvil and the spindle. In this case, each of them there are 200 thousandths of an inch for a total of 400,000 you need to subtract from the reading on the main scale. This micrometer here actually has a very thin anvil and spindle. The idea with this is to go down into tight spots, such as the groove on a rule or an O-ring groove in a shaft. That would be the purpose of this type of micrometer. This micrometer here actually has a couple of things going on. We have a very fat anvil and spindle for measuring across great distances, such as thread wires on a thread, where it would be very difficult to get a standard anvil and spindle over that. The other thing that's going on is this one actually has a digital readout. So this one has a mechanical scale also, but the digital readout allows us to see the reading quite easily on the display. This is actually a 1 to 2 inch micrometer, so what you would do is set it all the way in and over the standard, and you would set the 0 here. One thing that's really cool about it, let's say you got a lot of parts that are 1.5 inches in diameter. I could set it to 1.5 inches and then set 0, and then I could do comparison type measuring with it. Also too, it will toggle between inch and metric very easily, and again, I have on this particular model we have an inch scale here so we can check it. Not all digital mics will have this scale on it, but it's really nice to see that your readings are the same digital and mechanical in case there's an error. Another nice feature with this micrometer is it has this little area here where I can actually hook it up to a printer or a PC so you can print out a hard copy of the measurement. And if we have a look at the thread here, and I hold these two wires over top of the thread, now what we can do is we can put this very fat anvil over top of it, allowing us to measure. Moving on, the next micrometer that we have is a thread mic. Now this one here actually has a variety of anvils and spindles that we can put in. I'm going to try and zoom in a little bit on this so you can hopefully see the anvil and the spindle. Sorry. There we go. So we have a little V down here for the anvil and a sharp point here for the spindle. Okay, sharp point for the spindle. What's really nice with these is I can actually change the anvil and spindle for different threads per inch. So put it back in there. And there's a lock here with a floating anvil, so I can set 0 because the V's are going to be different sizes and the 0 will have to be adjusted. How this works is I can put it over top of the thread, and it's meant to measure pitch diameter is what's happening with this. I'm just going to zoom out a little bit. It's meant to measure pitch diameter. Now, if you had a really fine thread, you'd want to make sure you got over the crest of one thread and into the root of the thread exactly opposite this type of micrometer. Again, we're measuring pitch diameter with it, and we can take the reading off the scale, not the outside of the mic. Quite a handy mic. This one has a range of 0 to 1 inches, so I could end up getting other mics 1 to 2, 2 to 3, and again it has interchangeable anvil and spindle. This one here is a fixed a fixed threads per inch. So if you look here, I'll try and zoom in again. And it actually has, it says 8 to 13 here, so it's meant to measure between 8 threads per inch and 13 threads per inch. Again, we have the mechanical scale on it, and I'm hoping that you can see the anvil and spindle on this one. So the point and the V is what's happening with this. Thread mic. This one is for fixed sizes. Moving right along. What we have is a mic for measuring grooves. This particular mic is for measuring grooves. And again, we have the mechanical scale on it. So if I close it right up, it will have a set distance that it'll measure to. This one actually is to measure between 1 and 2 inches. So when it's all the way closed, it will measure 1 inch, a bore, a groove, a slot, whatever you need. And then as I wind it down, it expands the anvil and the spindle. I'd like you to notice the scale. The scale is actually running backwards on this micrometer, much like another mic I have shown you, the depth mic. So as you can see, we can actually use this micrometer to measure the bore of a part and take the measurement off of that. And as discussed, and you've seen in a previous video, this is a depth micrometer. Again, we have the scale that runs backwards. As we wind it down, we have the rod that appears out the bottom side of it. This will go on a flat surface, and this will extend into a groove, a hole, whatever we need. And again, we have the mechanical scale that we can read. If I want to change the rod, each rod has a travel of 1 inch. I can actually unscrew the cap here and I can put in a longer rod. Again, that can be seen in the depth micrometer video. The next micrometer I'm going to show you is a pin mic. So what we have is we have an anvil that is a pin, and we have the other end that looks like our standard micrometer on the spindle. The idea with this is to measure inside a bore, a bearing sleeve, a groove, a slot, something like that, and then just wind it down on that. Because we have an arc or a radius inside, we would end up getting a false reading if we just used a standard micrometer with a flat anvil. So a pin mic. You will notice, hopefully, that we can actually change the anvil, and I can put in different thicknesses, different shapes, things like that. This here is an intra mic, and how it works is I have the scale here, but I also have these 3 protruding pads. So as we adjust the size here, these pads will move in and out. It is meant for measuring bores, and this is a standard that it goes in. So what I would do is I would turn this until it fits into the bore and then check the size, but gives you an idea of how to measure a hole. It's a little nicer to use than an inside micrometer because it has that third leg, so you're not worried about whether you're over the exact middle of the bore or not. Last but not least, I know I showed you in the beginning an attachment with a ball mic, but this one here actually has a ball end for an anvil and a standard end for the spindle. Again, it's a great bearing mic. A mechanic may have this type of a micrometer for checking bearing shells as they have an arc on them. So I'm hoping you can see that, how the ball is actually sitting in the bore and it's contacting a point exactly opposite the spindle here, so we can measure the wall thickness of this particular piece of material, bearing, whatever. Those are the micrometers, some special micrometers, and this is just a small little sample of some of the micrometers that you may run into in the machine shop. Again, there's all kinds of different micrometers that will be used.